All right, this is a short video on 2.6. There were a couple examples we didn't get to in the higher order derivative section. So this number 6 says find the third derivative of g, and then we're going to evaluate that at 1. So we're going to go through and find the derivatives. So if we take g prime of x, bring the 4 to the front, lose a power, bring the 3 to the front, lose a power, and it's going to get times by the -2. And then 7 would just be by itself. So this is 4x cubed minus 6x squared plus 7. That's g prime. G double prime, we then take the derivative of g prime. So this is 4 times 3 would be 12x to the second. 2 times -6 would be -12x to the first. And the 7 would go away because it is a constant, and the derivative of a constant is 0. G triple prime would be 12 times 2, which is 24, x, lose a power, and then minus 12. Now we want to evaluate that at 1. So this is 24 times 1 minus 12, which ends up being positive 12. For number 8, we want to find g triple prime and then evaluate that at 0. This one would look like a product rule because you have a function times another function, but it's actually a lot easier just to distribute this and make it a polynomial that you can take just the power rule of. So I haven't taken a derivative yet, I'm just distributing that 4x cubed to everything in the function. So f prime of x would be 4 times 5 is 20, lose a power. -16 times 4 is -64, lose a power. 3 times 12 is 36, lose a power. F double prime of x is going to be 80, x to the third. -64 times the 3 you bring down to the front is -192, x squared, and then plus 72x for the last term. F triple prime of x would be 3 times the 80, which would be 240, x squared. 2 times the -192 is going to be -384x, and then 72 will be times 1, and then we lose the x. So then when we evaluate this at 0, notice that everything that has an x is going to go away. So your constant ends up just being the final part that's left over. So it's that 72. All right, and that was the only two that we had left from the higher order derivative section.